In these next three questions, we are going to work through how to find the time element involved when we know what our deposit is and we know what our savings goal is. This is a little bit more complicated, but we can handle it. We've done everything else. Again, we're using that basic simple interest formula of accumulated value is equal to the principal 1 plus the rate times time. Okay, so let's take on question number 6 with this in mind. Over here, I need some room. 6. Okay, we do invest $99,600. That's our principal. It pays 3.6% or 0.036. We'll put that in. How long will it take for this investment to double in value? So we want an accumulated value that's twice as big as what we put in. So on this one, I'm going to develop a process that will simplify what we're going to do. So we put in 9,600. Let's fill in what we know. We've got 1 plus the interest rate they gave us is 0.036, turning that percentage into a decimal. What we don't know is how many years we're going to leave it on deposit, so then we end up with double. Well, what's double? That's 2 times 9,600. You could do the math on that. That's 19,200. But I'm going to show you in a moment there's a reason I'm not going to do that math, because we're just going to undo it in the next step. So my suggestion in working this is some algebra. Remember, we can't multiply. Usually we go inside here, but we've got a variable, something we can't solve for. So we're going to divide both sides by 9,600. This whole side, that'll cancel out there. And then watch this. Those cancel, those cancel. So what are we left with? We're left with 2 over here, which is double what we wanted. So this is working the same way. We're going to use this process also. If I invested $1, when will I have $2? That's the same question. The amount is not important because we're doubling. Okay, and so since this is gone, we just have 1 plus 0.036t. Okay. We can subtract 1 from both sides. Again, taking us back to the algebra. That gives us 1, 0.036t. And since we can't multiply, we divide. So we're ending up with 1 divided by 0.036. That's what t is. So t is, doing the math, 27.8 years. Okay, so let's try it, but we're going to abbreviate the process a little bit when we get to 7. We're going to take advantage of it. We've got Jenelle, who's going to invest $500 in a savings account, paying 4.3% simple interest. She wants her money to triple, to become 3 times as big. So instead of putting in the amount of 500, because we really don't care, as long as it's $1, it's going to become $3. So we'll start with this. We've got 3 times the amount of whatever we started with. And then we only deal with the inside part, right? We don't need to put a principal. It's just $1. 1 plus 0.043t. We're going to subtract 1. And then divide. So this gives us 2. So we're going to see that t becomes equal to 2 divided by 0.043. Put that in your calculator, and you should get 46.5 years. Okay, see how nicely that works. Let's try one more example over here. So we're going to take question number 8. Same way. $1,200 in savings account, paying 5.1. How long will it take to double? Again, we're going to start right here. Double. We don't need to put in the deposit amount because that's going to cancel out in that first step anyway. So we want to double our money. And what do we know? It's really only based on the interest rate. So here's our money back plus 0.051% times the amount of time it's deposited. So again, we subtract 1 from both sides. That's our original deposit. And we're left with $1, 0.051 t. And so our time is equal to 1 divided by 0.051. And when we do the math on that, we get that that's 19.6 years. Okay,